From knowledge bases, to ontologies. This is episode 3, 40 Years of Evolution. In episode 2 we took an ontology apart and found its 5 building blocks. So here is a perfectly fair question. If the idea is this useful, where on earth has it been all this time? The answer turns out to be a surprisingly long story, one that runs from ancient Greek philosophy, through the very birth of artificial intelligence, and straight into the systems being built this year. 6 stages, 4 decades. Let us walk the whole arc together. Here is the shape of the journey, before we set off. The word ontology is older than computing by more than 2,000 years. And for almost all of that time, it lived purely inside philosophy. Then, in a single decisive move in the early 1990s, it crossed over into computer science. From there it rode 3 successive technology waves, the semantic web, the knowledge graph, and now the large language model, each one larger than the one before. And it is in this final wave that ontologies have quietly become essential infrastructure. Keep that arc in mind, because every single stage we visit is one more step along it. It all begins with the word itself. Ontology comes from the Greek, and it literally means the study of being, the study of what exists. For the ancient philosophers, this was one of the deepest questions a person could ask. What kinds of things are there in the world, and how do they relate to one another? Aristotle, famously, tried to sort the whole of existence into categories, substances, qualities, quantities, relations. And that instinct, to carve the world at its joints and carefully name the pieces, is the exact same instinct a modern ontology engineer brings to a domain. The tools changed completely. The underlying move did not change at all. So our first stage, everything before roughly the 1980s, is the philosophical era. Across 2 full millennia, ontology remained a branch of metaphysics, concerned with the nature of being in the abstract. It produced no software, and no standards whatsoever. But it did produce something that mattered enormously later on, a deep and disciplined habit of classification. The idea that you can take a messy world, identify its fundamental kinds, arrange them neatly into hierarchies, and then reason about them, was fully worked out by philosophers long before any machine existed that could use it. Computer science would later inherit that entire habit, wholesale. Stage 2 is the bridge, and it has a precise date and a name attached to it. In 1993, Tom Gruber, working at Stanford, deliberately borrowed this ancient philosophical word and handed it an engineering meaning. An ontology, he said, is a formal, explicit specification of a shared conceptualization. With that single sentence, ontology stopped being only a question about the nature of reality, and became a thing you could actually build, a concrete artifact that a computer could load up and use. This is the true hinge of the whole story. Everything before it is philosophy. Everything after it is computer science. But Gruber was certainly not working in a vacuum. Stage 3, running right through the 1980s and 90s, is when the formal machinery actually arrived. Artificial intelligence researchers had spent years wrestling with how to represent knowledge for a machine. Out of that struggle came frame systems, like the famous KLONE family, which organized knowledge into structured, inheritable templates. And right alongside them came description logics, a family of formal languages precise enough for a computer to reason over, and yet still decidable. Frames gave ontologies their structure. Description logic gave them their rigor. Together, the two turned Gruber's definition into something you could genuinely compute with. Stage 4 is where ontologies finally went public, and it carries a grand name, the Semantic Web. Around the turn of the millennium, Tim Berners-Lee, the inventor of the web itself, proposed a bold next step. What if web pages carried not just text for humans to read, but meaning that machines could understand? To make that real, the W3C, the Web Standards Body, published a whole stack of standards. In 2004, RDF, and OWL, the Web Ontology Language. In 2008, SPARQL, a query language for this new kind of linked data. And the linked open data movement began stitching public datasets together. For one glorious decade, ontologies were hailed as the foundation of the next internet. It is well worth seeing that stack laid out clearly, because you will meet every single layer again later in this series. At the very bottom sits the URI, a universal way to name absolutely anything. On top of that, RDF, which records every fact as one simple triple, a subject, a predicate, and an object. Then RDF schema, which adds classes and basic hierarchy. Then OWL, the full ontology language, carrying the rich axioms we met last episode. Sparkle sits across the top to query all of it. And linked data is simply the practice of connecting these graphs across the open web. URI, RDF, schema, OWL, SPARQL, linked data. That, right there, is the formal spine of the entire field. Stage 5 is the one that finally carried ontologies out of the research lab and into your pocket. In 2012, Google launched something it named the Knowledge Graph, the structured information panel that appears right beside your search results. Suddenly, ontology-style structured knowledge was quietly serving billions of queries every single day. Around it, enormous open knowledge bases grew up, DBpedia and Wikidata, harvesting structured facts from across the whole web. Graph databases, like Neo4j, matured to store all of it. This was the decade in which ontologies completed their long journey, from pure academic research into hard industrial application. The vocabulary shifted too, and the world started saying knowledge graph far more often than it said ontology. Which brings us to stage 6, the present moment, the large language model era, and a genuine plot twist. When models like the GPT family arrived, a great many people assumed they would simply make ontologies obsolete. Why painstakingly hand-build a knowledge structure, when a model has already read almost the entire web? But very nearly the opposite happened. As we saw back in episode 1, language models hallucinate, and their answers cannot be audited. So practitioners began pairing them with ontologies, the neural and the symbolic, working hand in hand. Ontology-grounded retrieval sharply cuts hallucination. Agents use ontologies to understand their own tools. And a whole wave of enterprise companies, Palantir, Stardog, Timbre, Siemens, built their entire platform squarely on this fusion. And the story has certainly not stopped here. The newest frontier, taking shape right now across 2025 and beyond, flips the relationship one more time. Instead of humans building ontologies for machines, we are beginning to let the machines help build the ontologies themselves. A large language model can now draft an ontology straight from raw text, propose the concepts that are missing, and suggest brand new axioms. Ontologies are becoming dynamic, evolving as a domain shifts rather than being frozen forever at design time. And inside multi-agent systems, a shared ontology is fast becoming the common language that lets independent agents actually coordinate. The map, in other words, is starting to draw, and redraw, itself. So let us take the whole 40-year arc in a single sweep. First, philosophy, the study of being, for 2,000 years. Then, in 1993, the bridge across into computer science. Through the 80s and 90s, the knowledge representation foundations, frames and description logic. Across the 2000s, the semantic web and its W3C standards. Through the 2010s, the knowledge graph and its decisive move into industry. In the 2020s, the large language model revival. And now, self-evolving ontologies. 6 stages, one continuous thread, with each new wave standing squarely on the shoulders of the one before it. Now step back, and one pattern jumps straight out at you. Not one of these waves ever truly replaced the one before it. The semantic web did not discard description logic, it standardized it. Knowledge graphs did not abandon ontologies, they simply put data on top of them. And large language models have not retired ontologies either, they have made them newly necessary, because a model that sounds right, yet cannot prove it, desperately needs a structure that can. And that is exactly why, after a full 40 years, this supposedly old idea is having its single biggest moment yet. The needed answers, machine understandable meaning, only grows as our systems grow more powerful. So that is the long arc, all the way from Aristotle's categories to self-evolving knowledge. An idea that has been quietly waiting, for 2,000 years, for the technology that would finally need it as much as we now do. Next time, we draw some sharp borders. Episode 4, Ontology versus its neighbors, where we finally separate it, cleanly, from knowledge graphs, from rule systems, and from large language models, and where you will meet that simple equation I keep promising you. See you there.